Well, my dear, now let's again begin with the same continuations of the dimension. I have in my first video I have completed till the angular velocity. Now my dimension number 7 is the dimension of frequency. You can see frequency, and this is dimension number 7, that is quantity named is frequency, and it is denoted by N or F, or you can say nu. Here I am writing nu, N-E-U, nu. My dear, here I will try my level best to explain you a little bit. The frequency, you all know that, sir, frequency is nothing but reciprocal of time period. Bacha, everybody know, I hope, frequency is the reciprocal of time period. That is 1 upon time, right? But denotion of frequency in some of the topics, some of the chapters, say if it is wave, it is sound wave. If it is sound wave, the sound frequency is denoted by N or F, because frequency is a letter starting with F. So in sound wave, it is denoted by N or F. But light wave frequency, because light is electromagnetic. So any electromagnetic wave frequency is denoted by nu. There we don't write N or F. Just speed of light is denoted by C. Rest of speed is denoted by V. But speed of light is denoted by C. As say the frequency of light is denoted by nu. Look at that, how I make. This is the way. This is the way. This is the way. V, and then turn it. This is the way. This is nu, my dear. So nu is the frequency of light, and N or F is also the denotion for frequency, but it is for frequency of sound wave, because sound is not an electromagnetic. So as far as electromagnetic frequency or denotion is concerned, it is nu only. So frequency of any electromagnetic wave, either ultraviolet, either so many electromagnetic wave, I talked in my first video of physical world. So any electromagnetic wave frequency is nu. But normal sound wave is frequency is denoted by N or F. So here I am writing the dimension of frequency, that is dimension of N or dimension of nu or dimension of F, is nothing but 1 upon dimension of T, because the formula of frequency is reciprocal of time period. Reciprocal of time period. Simple. So what is the dimension of N or dimension of nu? So dimension of N, that is frequency, or dimension of nu, that is also frequency, but one for sound, that is one for non-electromagnetic and one for electromagnetic. कोई फर्क नहीं पड़ता है. Definition formula is same. Either it is frequency of electromagnetic wave, then also it is reciprocal of time, or it is a frequency of non-electromagnetic wave, that is sound wave, it is 1 by time. So किसी का भी frequency, any frequency, either mechanics or electromagnetic, the frequency is formula is same, that is 1 upon T. So here the dimension is so simple. If it is 1 upon T, no length, so L power 0, no mass, M power 0, T power minus 1. T power minus 1. What is the SI unit of frequency? You can see SI unit of frequency is second inverse. Second inverse. है ना? T power minus 1. Rest all कुछ नहीं है. Second inverse or hertz. Hertz is the name of scientist, है ना? Hertz, name of scientist. So all letter is in small letter, hertz. So this is the dimension of frequency, my dear. Earlier I have done angular velocity. I think dimension for angular velocity and dimension for frequency is same. So nice. Again I got the quantity, dimension of angular velocity and dimension of frequency is same. And therefore, my dear, dimension of angular velocity or angular velocity is also called angular frequency. We will discuss in the other chapters. So now this is the dimension of frequency I have brought in front of you. Now let's go to the next one, dimension of electric charge. Electric charge denoted by Q. Dimension of electric charge denoted by Q. My dear, I in class 10th, in class I have visited to you all know that Q is equal to IT formula, that is Q, here I am writing, you all know that is QIT, QIT, That is the formula. Q, that is Q, I, and this is T. Q, I, T. That is Q is equal to I, T. So nice. So what is the dimension of electric charge? Dimension of electric charge is nothing but dimension of current multiplied by dimension of time. Dimension of current multiplied by dimension of time. Sir, charge is derived quantity. Yes, it is a derived quantity. You can see it is derived from fundamental quantity, that is electric current and time. So nice. So charge is which quantity? It is derived quantity. Everywhere. Frequency is which quantity? Derived quantity. It is derived by time. And time is which quantity? Fundamental. So here also charge is a derived quantity which is derived from two fundamental quantity, name are electric current and time. So now my dear, what is the dimension of charge? So dimension of charge is, sir, no length, you can see no length, L power 0, no mass, M power 0. So there is a time, T power 1, and there is a I, current. And current either you can write I power 1, either you write I power 1, or in place of I power 1 you can write L0, M0, T power 1, A power 1, where A stands for ampere. So while writing the dimension for current, my dear, the science has given a choice that either I can represent its dimension by alphabet I, or I can use its unit as a dimension. And what is its unit? Ampere. So the symbol of ampere is capital A. That symbol can be used as a dimension for current I. Or you can write I also. Both the answers are correct. So I hope dimension of charge is over. So this is the dimension of charge, my dear. L0, M0, T1, I1, or L0, M0, T1, A1. Where I or A, I is the current ka denotion, and A is the unit for the current, and science has given this option that either I can represent the dimension for current as I, or I can represent it as ampere, that is A power 1. So this is, my dear, I have covered with frequency and I covered with electric charge. Now let's go to the next quantity, that is electric potential. Electric potential. My dear, you all know electric potential is denoted by V, and now I will not wait much because you all know this kind of a formula. Electric potential is denoted by V, and the unit of the formula for electric potential is work done divided by charge. It is work in bringing a charge from infinity to that point. Remember class 10th ka definition, electric potential. It is the amount of work done in bringing the charge from infinity to that point. So the formula of electric potential is work upon charge. So what is the dimension for electric potential? It is a dimension of work. So dimension of electric potential is equal to the dimension of work divided by dimension of charge. Okay. So what is the dimension of work now? So dimension of work is nothing but, you all know, L2 M1 T minus 2. I told you, learn these dimensions. And dimension of charge I have written I1 T1 QIT. Here QIT. So Q can be written as I1 T1 QIT, where I and T are fundamental quantity. Okay, because I told you whenever you write dimension, as soon as you got the fundamental quantity, you stop there only. So here I convert the charge as QIT. So what is the dimension for charge? I1 T1 L0 M0. कुछ नहीं है length mass charge में. So what is the total dimension, my dear? Here is the total dimension. This is L2. This is M1. This is T minus 2, and this T1 will go up, become minus 1, and minus 2 become minus 3, and this I will go up, become I minus 1. So nice. Or you can write, or this dimension can be written as, or that is L2 M1 T minus 3 ampere minus 1. Because I said I can be written as ampere. So this can also be the answer, or this can also be the answer. It's all up to you whether you have to represent current as I or whether you have to represent it as ampere. Better, my point is, because formula is in I only, na? QIT. So instead of writing I as A, better you have this practice of writing in terms of I only. Okay, so I hope you are clear with the dimensions of this all, that this is nothing but, here you are sure that here it is electric potential, formula work upon charge. So dimension for electric potential is dimension of work divided by dimension of charge. Dimension of work is L2 m1 t minus 2, charge is it QIT, that is I1 T1. So what is entire dimension? L2, denominator में कोई length नहीं है, it is remain L2. M1, denominator में there is no mass, it remain M1. T power minus 2, in denominator it is T power 1. Go up, become T power minus 3, minus 2 minus 1, and I will go up, become I power minus 1. So either you leave your dimension here only, this is the dimension of electric potential, L2 M1 T minus 3 I minus 1, or you can write L2 M1 T minus 3 A power minus 1 in place of I as ampere. So I hope it is clear. Pause the video, write it down, and then I will go for dimension for electric resistance and potential gradient. So my dear, the next dimension is electric resistance. So now here I am writing dimension number 10, electric resistance, or you are saying normally resistance, denoted by R. So now my dear, you all know that R ka formula is V upon I, that is electric potential divided by current. So now here R is, what is electric potential? Work upon charge upon I. I hope it is clear, because electric potential is given by work upon charge, and work upon charge whole divided by I. Now this can be written as work divided by QI. Work divided by QI, because this Q and I get multiplied. So now what will be the dimension for R? Dimension of R is equal to dimension of work divided by dimension of Q multiplied by dimension of I. So you all know that, my dear, dimension of work is L2 M1 T minus 2 divided by dimension of Q is I power 1 T power 1, that is QIT. कितने देर से I am doing this? For so many example I did it. अब तक you must be learned also that QIT, Q is equal to I power 1 T power 1 dimension, and here there is one more I, so here it is I power 1 as it is. So now what is the dimension for R? The dimension of R is, let us solve this, L2 in numerator, no nothing in denominator with mass, length, mass M1, no nothing in denominator with mass, M1 as it is, here minus 2, here it is T1. So T1 and 1 will go up, minus 2 and minus 1 become minus 3, and this is I1 and this is I1. This I1 and I1 become I power 2. Here I can write one more step, L2 M1 T minus 2 divided by, this is I2 T1, I1 and I1 I2. So now what will happen? L2 M1 T minus 2 and this one will go up, become minus 3, and I will go up, become minus 2. Or I can write this as L2 M1 T minus 3 A minus 2. In place of I can write ampere, that is equal to resistance. This is the dimension of resistance, electric resistance. You can check it out with that 94 dimension which is given in NCERT. Let's see, and today you'll be so happy, sir, we are getting the right answers. So happy you all. And this is the dimensions, my dear, for resistance. Only take care that either you represent with the electric current or you can represent this with ampere. No issues about it. I hope it is clear. Now let's go to the next quantity on the board. 11th number. Potential gradient. Potential gradient. My dear, now here some of the physical quantity don't have any abbreviations. You can see potential gradient don't have any abbreviation. Am I clear? Generally we have this abbreviation denoted by K. Potential gradient denoted by K. But sometimes the physical quantity have name, but they don't have any abbreviation or representation. Like resistance as R, potential as V, current as I. but not every time the quantity has some abbreviation, not necessary. You can put your abbreviation from your side. Here potential gradient I have denoted by K. And my dear, let me tell you one concept, because from 11th dimension you will observe gradient, potential gradient, pressure gradient, temperature gradient, velocity gradient. Why I am emphasizing this word gradient? Because my dear, according to physics, there is some logic. Whenever any quantity is named with gradient, here the quantity is potential, it is named with gradient. Here the quantity is pressure, it is named with gradient. Here the quantity is temperature, named with gradient. Quantity is velocity, named with gradient. So any quantity when named with gradient, that quantity is divided by distance. That's the logic. That quantity will divide by distance. Please take care. This is what is an important lecture to you all. So potential gradient, sir, potential gradient, that is K denotion, is potential divided by distance. Potential divided by distance. And one more thing, my dear, let me tell you, this potential is coming in electricity. This is K, dimension of K, dimension of potential divided by dimension of distance. Distance को मैंने L ले लिया, because distance का dimension is L. Now dimension of potential suppose मेरे को learn नहीं है, so I will write work upon charge upon length. See, it's not necessary कि you remember the dimension for potential. नहीं learn है, कोई issue नहीं, but formula तो है. And then this will be potential gradient dimension K will equal to that. This is dimension of work divided by QL. Dimension of Q, dimension of L. QL. This is dimension of K. Now work dimension everybody know. L2 M1 T minus 2. Charge dimension I1 T1. Charge ka dimension QIT. So many places I have written. So important is the dimension of electric charge. So important. So many places we are using. If I don't know charge dimension, I cannot find electric potential, I cannot find electric resistance, I cannot find potential gradient, forget it. So this is, charge is I1 T1 and this is L power 1. This is L power 1. So now what will be the dimension further? What will be the dimension? Now crack it. So dimension of potential gradient K is L2 and denominator it is L1. This will go up 2 minus 1 L1. Mass M1. No mass in denominator. T minus 2. This 1 will go up, become minus 1. It become minus 3. And I will go up, become 1, minus 1 and I minus 1. Or you can write this as L1 M1 T minus 3 A power minus 1. I power minus 1 can be written as ampere power minus 1. So I hope, my dear, dimension number 10 and dimension number 11 is clear. Please write it down, pause the video, then I will go for the next dimensions. Well, now let's move to the dimension number 12. The dimension number 12 is pressure gradient. Pressure gradient. Okay, now I am not denoting this with any alphabet because I don't have, it is depend upon us that we are taking during the question. If it is there, we ourselves take some denotation for it, no issues. Let this represent pressure gradient. So I am writing as it is, but I have given one logic that any quantity is ended with the word gradient, that quantity will divide by distance. So the pressure gradient will be, sir, pressure divided by distance. So nice. Pressure gradient, pressure divided by distance. So what is dimension of pressure gradient? So dimension of pressure gradient, I have written box में, dimension of pressure gradient is equal to dimension of pressure divided by dimension of distance. So easy now. So dimension of pressure gradient is equal to dimension of pressure. याद करो, I have given you in my starting में, video के start में, today only. So you learn the 5 dimensions. What is dimension of pressure? L power minus 1, M power 1, T power minus 2. Divide by distance. L power 1. Distance L power 1. So what is the dimension for pressure gradient? The dimension for pressure gradient is equal to, this is minus 1 and this is 1. This one go up. This one go up, become minus 1. Minus 1 and minus 1. L power minus 2, M power 1, T power minus 2. That's all. Dimension of pressure gradient is over. Believe me, my dear, I have done here 20 dimension. I'll go more than 20, 21, 22, 23 dimensions and 10 already solved. 33, 34 dimensions I already taken, my dear, out of 94. Now I want everybody should work hard. I am doing this only for you because most of the students have subscribed my YouTube channel. And I want, my dear, if student has subscribed, they should get something very important, which is very important, dimensions, my dear, so that you should not feel any kind of difficulty while solving the dimensions for any physical quantity. Okay, now let's go to the next dimension. Dimension number 13, temperature gradient. Temperature gradient. So here, this is temperature gradient. So again, this quantity, temperature is ended with the word gradient. So temperature will divide by distance. So what is the dimension of temperature gradient? So here it is temperature gradient. Dimension of temperature gradient is nothing but dimension of temperature divided by dimension of distance. See, everywhere I am writing dimension box. Look at it. That's a method of, any teacher will look this, they will be very happy that my kids is knowing how to represent. Anybody can say, sir, you are finding dimension of temperature, you are finding dimension of distance, so that you found the dimension of temperature gradient. So now, my dear, here temperature is a fundamental quantity and distance is also a fundamental quantity. Oh God, temperature gradient is derived quantity, which is derived from fundamental quantity. जितना भी मैंने लिखा है सब derived quantity है, they are deriving from the fundamental. Here pressure was not fundamental, but you know I have converted pressure earlier while doing pressure का topic on 10 dimensions में. I converted the pressure in terms of fundamental. Please, you go at the back by force upon area. Then force is converted into fundamental, area is converted into fundamental. I don't want to repeat all those stuff now. Here I have directly substituted dimension of pressure. Because as the chapter go up further and further, my dear, you should have a more maturity of substituting the dimension directly. Now here temperature is a fundamental and distance is a fundamental. So what is the dimension for temperature gradient? Dimension for temperature gradient is nothing but dimension of temperature is, my dear, generally I can write T because it is a fundamental quantity, but T represent time. T represent time. So here, my dear, the dimension for temperature we write Kelvin. K, Kelvin, Kelvin. Please take care. As dimension of current we write ampere. Dimension of temperature we write Kelvin. Here one point, my dear, you should ask me this question. Sir, whenever we represent dimension, take 2 minutes. Whenever we take a dimension, we write in terms of quantity. That is length के लिए L, mass के लिए M, time के लिए T, current के लिए I. Right? We never write their unit. But my dear, except one fundamental quantity, that is temperature. For unit ampere के लिए भी we write current के लिए ampere. But in case of current, the science has given us two alternatives. Either I can write the dimension of current as I, or I can write the dimension of current as ampere. But for temperature, my dear, science has not given any alternative. They said, since temperature ka alphabet is T, so if I use the word T, it is time. And therefore, to avoid this T का confusion, because T is only for time and time and time. It's not for temperature. So what to do for temperature? We will write its unit as a dimension. We will write its unit as a dimension. So what is the dimension for temperature? So dimension for temperature is Kelvin, capital K in the box. Divided by dimension of distance, you all know L power 1. So what is the dimension for temperature gradient? So dimension of temperature gradient will be nothing but L power minus 1. This one will go up because I have to start with L only. L power minus 1, mass नहीं है, M power 0, time नहीं है, T power 0, and Kelvin, K power 1. Kelvin is there, K power 1. Oh God, now you begin with, now you can see from so many topics, from electric potential, electric resistance, potential gradient, temperature gradient, there are 4 dimensions, 4 quantity are in the box. 4 quantity are in the box. Earlier it was length, mass, time and current was coming in the box. See my these all examples. There current is coming, 4th quantity. 7 में से 4 physical fundamental quantity are coming in dimensions, my dear. Now you become more matured. Look at the 4 quantity you can see. Earlier also in these all examples, resistance, potential, आपको length, mass, time और current 4 quantity दिख रहा था. Here also 4 quantity, length, mass, time and temperature. But temperature का T instead of that we will confuse with time, and therefore science told, hey, temperature का dimensions you will write as Kelvin K power 1. I hope it is clear. So formula is temperature upon distance. Temperature का dimension is Kelvin. So this is Kelvin power 1 because only one temperature. Distance का भी only 1. So L power 1. Then I solve this in terms of length, mass, time, because whenever we end the dimension, whenever we end with the dimension, better write, even the mass is not there, even the time is not there. I told in my first video only, please write then also power 0, power 0. जब आप ज़्यादा बड़े हो जाओगे, then you can write this in short. This is L power minus 1, K power 1. Because these two are 0, no need of writing. But not now. Not now because now you are learning. So please pause the video once again. I have completed pressure gradient and temperature gradient. Now I will go for velocity gradient. Pause the video, write this too. Then I will go for velocity gradient. Fast. Well, my dear, now let's go to the next physical quantity, that is velocity gradient. Quantity number 14. Velocity gradient. So easy. Velocity gradient, nothing but velocity divided by distance. So nice, because I told you any physical quantity when ended with distance, divide that quantity with, when ended with gradient, divide that quantity with distance. Pressure gradient, pressure divided by distance. Temperature gradient, temperature divided by distance. Velocity gradient, velocity divided by distance. Potential gradient, potential divided by distance. Have a logic of learning of this science. Now next is velocity gradient. So here the dimension of velocity gradient, again there is no denotation. We can use our denotation by saying let this is velocity gradient, but that is not intention right now. We are proving the dimension that what will be. So here the velocity gradient is velocity, that is dimension of velocity upon dimension of distance. Okay, so dimension of velocity gradient will be nothing but dimension of velocity is nothing but L1 M0 T minus 1. That is dimension of velocity, and dimension of distance is L power 1. So nice. So what is the dimension of velocity gradient? The dimension of velocity gradient will be equal to, come on, L power 1 and this is power 1, L power 0, M power 0, T power minus 1. Beautiful. Oh God, the velocity gradient has the same dimension as the frequency. Frequency is also T power minus 1, 1 upon time. So nice. But, sir, the velocity gradient don't have the unit hertz. Second inverse you can write, second inverse. Velocity gradient second inverse because it is T power minus 1, second inverse. Frequency also have a unit second inverse. But frequency has one more unit, hertz. Sir, I cannot use hertz of frequency unit in velocity gradient, though they have same dimension. Unit is the second inverse. Frequency the unit is second inverse, but frequency में एक और unit है, that is hertz. Sir, that hertz cannot be written for velocity gradient because hertz has work for frequency. Hertz ने frequency के लिए काम किया. Frank Hertz experiments for frequency. He has not done any experiment for velocity gradient. हाँ, it is fortunate or unfortunate that dimension of velocity gradient and dimension of frequency is same. And for that reason, I am using one of the unit that is second inverse for both. But one more unit that is hertz, which is given for frequency, cannot be used in velocity gradient. See, these things are very important to listen my talks very well. Why hertz I cannot use here? I am using second inverse, but I am not using hertz unit. Why? Because sir, hertz work, hertz discover, hertz done experiment on frequencies. He has not discovered or done any work or any experiment with velocity gradient. So by looking dimension, second inverse can be a unit, but hertz cannot be a unit because hertz is a name of scientist and that scientist has work on frequency. And therefore that frequency ka unit hertz is given only to the frequency. It is same as the joule. The joule unit is only given to the work. It is not given to torque, though work and torque has the same dimension. So take care of these talks. Okay, now let's go to the next quantity, my dear. The next quantity is coefficient of viscosity. Beautiful quantity, coefficient of viscosity. And it is denoted by eta. Here I am writing E-double-T-A, eta. Eta. And look at the way of writing. N करके ऐसे N बना के इसको नीचे करना है. N बनाया, N बना के इसको नीचे तक लेकर ऐसे लंबा कर दो. That's eta denotion. Eta. Eta. Now my dear, this quantity का concept पहले मैं बताऊंगा because बीच में gradient था, there is nothing to discuss because gradient word मतलब the potential is divided by distance. So अभी इसमें कोई concept नहीं. You know potential क्या है? Pressure divided by distance. You know pressure क्या है? Temperature divided by distance. You know temperature क्या है? Velocity divided by distance. You know velocity क्या है? तो यहाँ कोई concept नहीं था. Right, but here there is a concept coefficient of viscosity which is denoted by eta. Sir, ये quantity मिलता किधर है? Where we exist this quantity? My dear, this is again a property of liquid. This is due to, this quantity is coming due to property of liquid. And listen to me carefully, कहाँ पर? My dear, as we are walking on the solid surface, 2 minutes सुन लो. As we are walking on the solid surface opposes our motion. Everybody from lower class knowing this language. When we move on the solid surface opposes our motion. And that is called frictional force. When solid oppose our motion, solid surface when oppose our motion is called frictional force. But when liquid opposes our motion, while swimming, my dear, so many people knows while swimming, water opposes, liquid oppose our motion. We wanted to go ahead in liquid, in water, and water forcing our body to go back, opposing. And that force is called, by which the water opposing our motion, that force is called dragged force. Thoda concept is required somewhere. It is called dragged force. Sir, liquid opposes the motion? Yes, liquid opposes the motion when we flow through the liquid. And by what force liquid will oppose our motion? By drag force. Liquid apply drag force. And that drag force, dragged मतलब होता ही है dragged, pushing, opposing, dragging. So that's drag force is also called viscous force. So nice. Viscous force. And this viscous force is a term related to viscosity. It becomes property of liquid. Now मैं इसको open करता हूँ. This is a property, sir. Viscosity is a term, is a property of a liquid due to which liquid exert a viscous or a drag force on us when we move through it. And that viscous force is denoted by F. which is directly proportional to, I'm proving this all, I'm going to eta. So this viscous or a drag force which is exerted by liquid on our body, that viscous force is directly proportional to area of layers of liquid. My dear, when we talk about liquid are in the form of layers. Liquid layers form में होता है. अपने को दिखता नहीं है, but when you'll observe in microscope, you'll observe the layer of the liquid. 1 layer, 2 layer, 3 layers. So my dear, this viscous or a drag force which is acting on our body while moving through the liquid, which is applied by the liquid on us, is directly proportional to sir area of the layer. कितने layer of area ने वो force लगाया, that is directly proportional to area of layer. And also directly proportional to, that is multiplied by velocity gradient. Superb. And this is the reason why मैंने आपको velocity gradient पहले 14th number पे सिखाया, and then on 15th number I am teaching you the topic of coefficient of viscosity, because coefficient of viscosity carrying the formula of velocity gradient. So nice this topic is. So now this F directly proportional to, I remove by equality sign, and here I use a constant, and that constant is called coefficient of viscosity. So this become constant multiplied by area multiplied by velocity gradient. Oh, so nice. Where eta is constant called as coefficient of viscosity. Why I am emphasizing so much here, my dear? Sometime in our exam we will ask you this question. Do you think, because I said in my one of the video plane angle and solid angle, I said constant don't have dimension. But which constant? Number constant. Number 4, 5, 6, 7, 8, 9. These are numbers are constant. These numbers don't have dimension. But all constant don't have dimension. This is wrong. This is wrong to say. इसलिए मैं इतना पढ़ा रहा हूँ. I wanted to prove, I wanted to show you that this coefficient of viscosity is the dimension. This is the dimension.